Hello everyone, this is Jessica, your math teacher. I have more than 15 years of teaching experience in Singapore. My subjects of interest are mainly A-level, O-level, and PSLE mathematics. I came to Singapore when I was 13 years old as a PSC scholar. I was then graduated from the National University of Singapore, majoring in mathematics. After that, I went to Switzerland to get my master courses in mathematics from the University of Geneva. Professionally speaking, I used to work as a banker in DBS Singapore and also as a correspondent in the United Nations office in Geneva. Most importantly, I'm a math teacher who has developed my own methods of teaching using the step-by-step and keyword method. I have taught so many students who could achieve A in the shortest period of time using these most efficient and effective methods, and I believe you could do that too. I hope all of you could achieve the best you could in life, and I'm looking forward to seeing you in class. Hello everyone, this is Jessica. Today I'm going to talk about a real A-level math question. So for this question on screen, it was pulled out from the 2014 H2 math paper. I think to some, this question might look very long and tedious, and it might be difficult to solve. But fret not. Today I'm going to guide you through how to solve this question using the easiest step-by-step method. Before you start to read word by word this question, I may ask you to pause over there and let's browse through the question and look for the keyword only. But what are the keywords? Don't worry, I'll give you a list with all the keywords that you may encounter during the A-level exam so that you can refer to them and link them to the corresponding techniques to solve the question. For this particular question, there is only one keyword among all these words, that is maximum. Once you spot on the maximum, you should know that you need to use differentiation to solve, and d something over d something equals to 0. Similarly, not just constrained to maximum. So once you see minimum, maximization, minimization, optimization, and so forth, one of the keywords that you spot on, you need to use d something over d something equals to 0. So what are the something and something? It depends on what's after maximum. For this question, it's the maximum of V for volume. So the upper one is dV. How about the lower one? The lower one is a matching pair to the upper one. In this case, what corresponds to V is R. So dV dr equals to 0. But how do I know which is a matching pair to the upper one? Don't worry, I'll also give you another list with all the matching pairs so that you can pick the correct one. I'll give you another example. If you see inside the question, maximum value of A for area, then it should be dA dr equals to 0. Once you derived dV dr equals to 0, congratulations, you have actually completed the most critical part of this question. The next step is to express the upper part of D, which is V in this case, in terms of the lower part of D, which is R in this case. So V equals to something to do with R. V is the volume of this figure. So V equals to the volume of the hemisphere plus the volume of the cone. Also note that the formula to calculate the volume for both are actually given inside the question, with a small twist that the volume of the hemisphere is half of the volume of the sphere. Now we examine the right-hand side of this equation. Is R the only variable over there? We have the numbers including pi, because pi is also a number. We have R and we have H. In this question, H does not have any fixed value, so H is also an unknown variable, but we want R to be the only variable on the right-hand side. So what should we do? We can eliminate H by expressing H in terms of R. Now what we need to do is to find the link between H and R, and we can see a right angle triangle over there linking both. In this right angle triangle, we can use the Pythagoras theorem, R squared plus H squared equals to 4 squared, and then we can express H in terms of R. We then plug this expression back to the original equation to get V equals to something to do with R. And great, we are now at the final step, which is to perform the differentiation and calculate dV dr. If you haven't learned how to perform the differentiation, you can refer to my class on the techniques of differentiation. And before you realize it, you have solved the question. To sum up, although this question might seem to be long and wordy, but all you need to do is to locate the keyword, which is maximum. And once you see the maximum of V, you should write down dv dr equals to 0, then express v in terms of r, and finally perform the differentiation and solve accordingly. In addition, if you want to know why the maximum of v means dv dr equals to 0, please refer to my differentiation class for the easy explanation. For this video, we only talk about how to solve this question step by step. Now you can go and search all the maximization minimization problem and try to solve using the exact same steps. Thank you for watching, and I hope you enjoyed today's video. I'll see you next time.